In section 3, we're going to talk about the addition and subtraction identities. So sometimes it's necessary to find the trig values of two angles added together. So this would be a case of an angle we're given that's not on a unit circle, but we would like to know its exact value. One of the most important things to remember in this section is that cosine of x plus y does not equal cosine of x plus cosine of y. This is never true. So when we're doing addition of two angles, we want to use our identities. So sine of x plus y is equal to sine of x times cosine of y plus cosine of x times sine of y. And you can read the other ones on your own. But we're going to use these identities to find sine and cosine trig values given angles that are not on the unit circle. So our first example, we want to find the exact value of cosine of 5 pi over 12. And 5 pi over 12 is not a value on our unit circle. So what we want to do is find two angles on our unit circle that add to 5 pi over 12. So let's start by listing our angles that are in quadrant 1. And we're going to list them in radians since 5 pi over 12 is in radians. We have pi over 6, pi over 4, and pi over 3. So we want to see if a combination of those two angles add to give us 5 pi over 12. Now right now with our denominators of 6, 4, and 3, we can't readily identify which two we want to use. So we want to go ahead and rewrite them with denominators of 12. So multiply pi over 6 by 2, pi over 4 by 3, and pi over 3 by 4. So now we're looking at the angles 2 pi over 12, 3 pi over 12, and 4 pi over 12. And we see 2 pi over 12 plus 3 pi over 12 is 5 pi over 12, which means we want to use pi over 6 and pi over 4. They will add to give us 5 pi over 12. So what we're going to do now is identify x and y that we want to plug into our sum formula for cosine. So we're going to let x equal pi over 4 and y equal pi over 6. Now, because this is addition and the order of addition does not matter, we could have easily chosen x to be pi over 6 and y to be pi over 4. So now we're going to go ahead and plug it into our function. So we have cosine of x, pi over 4, plus y, pi over 6, equals cosine of x, so cosine of pi over 4 times cosine of y, which is pi over 6, minus sine of x, which is pi over 4, times sine of y, which is pi over 6. So now pi over 4 and pi over 6 are on the unit circle. So using our unit circle, cosine of pi over 4 is radical 2 over 2 times the cosine of pi over 6, which is radical 3 over 2, minus sine of pi over 4, which is radical 2 over 2, times sine of pi over 6, which is 1/2. So it's going to be very important in this section of notes that you have your unit circle handy while you're doing these problems. So radical 2 over 2 times radical 3 over 2 is radical 6 over 4, minus radical 2 over 2 times 1/2, which is radical 2 over 4. And because they have the same denominator, I can write it as a single fraction as radical 6 minus radical 2 all over 4. So that is the exact value for cosine of 5 pi over 12. So next we want to find the exact value of sine of negative 15. So we're in degrees, so we're going to start with our quadrant 1 angles, 30 degrees, 45 degrees, and 60 degrees. And if I do 30 minus 45, we get negative 15. So 30 degrees and 45 degrees are the angles we're going to use for X and Y. And because it is addition, the order does matter. So we're going to pick X to be 30 and Y to be 45, because 30 minus 45 is negative 15. So using our subtraction formula, sine of 30 minus 45, we have sine of X, so sine of 30 times cosine of Y, cosine of 45, minus cosine of X, cosine of 30, times sine of Y, which is sine of 45. And again, now it just becomes using our unit circle. So sine of 30 degrees is 1/2 times cosine of 45 degrees, which is radical 2 over 2, minus cosine of 30 degrees, which is radical 3 over 2, times sine of 45 degrees, which is radical 2 over 2. So 1/2 times radical 2 over 2 is radical 2 over 4, minus radical 3 over 2 times radical 2 over 2 is radical 6 over 4. Again, we have common denominators, so I can write it as radical 2 minus radical 6 all over 4. Now you can notice that this is a very similar fraction to our first example, and that's because the angles we're going to pick are going to be a combination of our 30, 45, or 60 degree angles. And all of those values are either radical 3 over 2, 1/2, or radical 2 over 2. So we're going to get a lot of our values to be very, very similar. The only difference is going to be a positive or a negative in there. Going to our last example, sine of 17 pi over 12. Now, if you look back at that first example we did, where we looked in quadrant 1 at our angles, we had and wrote them in terms of denominators of 12. We had 3 pi over 12, 4 pi over 12, and 2 pi over 12. No combination of those three angles are going to get us 17 pi over 12, which means we're going to have to move on to a different quadrant to find our two angles that add to give us 17 pi over 12. So let's move to quadrant 2. So in quadrant 2, we have the angles 2 pi over 3, 3 pi over 4, and 5 pi over 6. And again, we have denominators of 3, 4, and 6, so in order to identify which two add to give us 17 pi over 12, we want to multiply our first fraction by 4, our second fraction by 3, and our last fraction by 2. So we're looking at the angles 8 pi over 12, 9 pi over 12, and 10 pi over 12. And if we look, 9 plus 8 is 17. So if I add my 2 pi over 3 angle with my 3 pi over 4 angle, we're going to get 17 pi over 12. So we're going to let x equal 2 pi over 3 and y equal 3 pi over 4 and plug it into our sum identity for sine. So we get sine of 2 pi over 3 plus 3 pi over 4 equals sine of x. So sine of 2 pi over 3 times cosine of y, which is cosine 3 pi over 4, plus cosine of x, so cosine of 2 pi over 3, times sine of y, which is 3 pi over 4. So now we're using the unit circle again. Sine of 2 pi over 3 is radical 3 over 2, times cosine of 3 pi over 4, which is negative radical 2 over 2. Because we are now in quadrant 2, cosine is negative in quadrant 2, plus cosine of 2 pi over 3, which is negative 1/2, times sine of 3 pi over 4, which is radical 2 over 2. So radical 3 over 2 times negative radical 2 over 2 will give us a negative radical 6 over 4. And because I'm adding negative 1/2 times radical 2 over 2, we'll get minus radical 2 over 4. We have common denominators, which means I can write my final answer as negative radical 6 minus radical 2 all over 4. Next, we want to simplify the expression cosine of x minus pi over 2. Well, I already have it written in the form of subtraction using cosine, where x equals x and y equals pi over 2. So I'm just going to use our subtraction identity to rewrite cosine of x minus pi over 2. We're going to get cosine of x times cosine of y, which in this case is pi over 2, plus sine of x times sine of y, which is pi over 2. Because the variable x is still x, cosine of x will stay cosine of x. Using the unit circle, cosine of pi over 2 is 0, so it's cosine of x times 0, plus sine of x will stay sine of x times sine of pi over 2, which is 1. Cosine of x times 0 is 0, so we're left with just sine of x times 1, which is sine of x. So this tells me no matter what value I plug in for x, because I'm subtracting pi over 2 from it, it's the same thing as if I were to just evaluate my function for sine instead. We can also prove identities using our sum and difference identities. So I want to prove 2 cosine of x sine of y is equal to sine of x plus y minus sine of x minus y. So I'm just going to use the sum and difference identities for sine to simplify that right side. So sine of x plus y is sine of x cosine of y plus cosine of x sine of y. And then we have minus sine of x minus y. And I have to put the sine of x minus y in parentheses because we are subtracting the entire thing. So sine of x minus y is sine of x cosine of y minus cosine of x sine of y. My next step is going to be to distribute the negative into our parentheses. So we end up with sine of x cosine of y plus cosine of x sine of y minus sine of x cosine of y. And then because I distribute the negative to a minus, we get plus cosine of x sine of y. So now I just figure if I have like terms. Well, we have a sine of x cosine of y and a minus sine of x cosine of y. So those are going to cancel. So we're left with cosine of x sine of y plus cosine of x sine of y, which gives us 2 cosine of x sine of y. And we have proven our identity. So not only do sine and cosine have addition and subtraction identities, but tangent does as well. So the addition identity for tangent, so tangent of x plus y, is tangent of x plus tangent of y over 1 minus tangent of x tangent of y. And tangent of x minus y is tangent of x minus tangent of y all over 1 plus tangent of x tangent of y. So we want to find the exact value of tangent of 17 pi over 12. Well, we already found sine of 17 pi over 12, so we know which two angles to use. We know that x is going to equal 2 pi over 3, and y is going to equal 3 pi over 4. So that tells us that tangent of 2 pi over 3 plus 3 pi over 4 equals tangent of 2 pi over 3 plus tangent of 3 pi over 4 all over 1 minus tangent of 2 pi over 3 times tangent of 3 pi over 4. So now all you have to do is use the unit circle to find tangent of 2 pi over 3 and tangent of 3 pi over 4. So let's start with tangent of 2 pi over 3. So on the unit circle, 2 pi over 3 is the point -1/2 radical 3 over 2. Tangent of that is going to be sine over cosine. So it's going to be radical 3 over 2 divided by -1/2. And as I've stated before, when I'm dividing two fractions with the same denominator, I'm just dividing their numerator. So radical 3 over 2 over negative radical 3 over 2 divided by -1/2 is just negative radical 3 plus tangent of 3 pi over 4. Well, on the unit circle, 3 pi over 4 is the point negative radical 2 over 2, comma radical 2 over 2. So when we divide those, because they're the same thing, one's positive, one negative, we're going to get -1 when we divide them. All over 1 minus negative radical 3 times -1. So my numerator is going to become negative radical 3 minus 1, since plus and negative becomes subtraction. And my denominator is going to stay 1 minus, because we're doing negative radical 3 times a positive 1, so it'll become a positive radical 3. And this can't simplify any further, so our final answer is negative radical 3 minus 1 all over 1 minus radical 3. So that is the exact value of tangent of 17 pi over 12. Next, we want to find the exact value of cotangent of 17 pi over 12. Well, because it's the same angle, we know x has to equal 2 pi over 3 and y equals 3 pi over 4. Now, we haven't talked about sum and difference identities for cotangent, but remember, cotangent is the reciprocal of tangent. So what that tells me is that cotangent of 17 pi over 12 equals 1 over tangent of 17 pi over 12. That also means the same thing as 1 over tangent of 2 pi over 3 plus 3 pi over 4. So the way I find cotangent of 17 pi over 12 is just to flip the sum identity for tangent. So it's going to be 1 minus tangent of 2 pi over 3 tangent of 3 pi over 4 all over tangent of 2 pi over 3 tangent 3 pi over 4. And we just found all of these values, so we get 1 minus negative radical 3 times -1 all over negative radical 3 plus a -1, which becomes 1 minus radical 3 all over negative radical 3 minus 1. Also, you could have recognized that because cotangent is the reciprocal of tangent, the value of cotangent of 17 pi over 12 is just the reciprocal of tangent of 17 pi over 12. So 1 minus radical 3 all over radical 3 minus 1 is the reciprocal of negative radical 3 minus 1 over 1 minus radical 3. So now we're going to do some mixed examples. So we're given sine of x equals 2/5 and cosine of y is -3/4. And both our angles are in the second quadrant, and we want to find sine of x minus y and then tangent of x minus y. So I'm going to start by writing down the identity of the difference identity for sine. So it is sine of x cosine of y minus cosine of x sine of y. So we need sine of x, which we have, and cosine of y, which we have, but we also need cosine of x and sine of y, which we do not have. But we do have enough information to find them. So if I use my information of sine of x, if I have my right triangle and my angle x, sine is 2/5, which means my opposite side is 2 and my hypotenuse is 5. And using my information about cosine of y, the adjacent side is -3 and my hypotenuse is 4. We have enough information to find the missing side to find sine and cosine. So using the Pythagorean theorem, we end up with the adjacent side being the square root of 21 in our first triangle. And using the Pythagorean theorem, the opposite side in our second triangle will be radical 7. Now, we are in the second quadrant. In quadrant 2, cosine is negative, which means in my first triangle, my adjacent side is actually a negative radical 21. So we now have enough information to replace sine of x, cosine of y, cosine of x, and sine of y with their ratios. So we're given sine of x is 2/5, so 2/5 times cosine of y, which is -3/4, minus cosine of x, which is going to be negative radical 21 over 5, times sine of y, which is radical 7 over 4. 2/5 times -3/4 is going to give us -6/20. And then we have minus a negative, so it's going to change to plus radical 147 over 20. So not only do we want to write this as a single fraction, but we want to simplify our radical as well. So radical 147, I can rewrite that as radical 49 times radical 3. And the square root of 49 is 7. So I write this as a single fraction over 20, we get -6 plus 7 radical 3. And that is the exact value given our ratios. Now we want to find tangent of x minus y. So it's going to be the same triangle. And first I'm going to write down the difference identity for tangent. So tangent of x minus tangent of y all over 1 plus tangent of x times tangent of y. So now we just have to replace our tangent of x and tangent of y with the ratios. Same two triangles we used in the previous example. So tangent of x is going to be opposite 2 over adjacent, which is negative radical 21. So it's -2 over radical 21 minus tangent of y, whose opposite side is radical 7, over the adjacent side -3, so it's negative radical 7 over 3, all over 1 plus tangent of x, so negative radical 2, -2 over radical 21 times negative radical 7 over 3. So first I can rewrite my numerator as -2 over radical 21 plus radical 7 over 3. And we can rewrite the denominator as 1 plus 2 radical 7 over 3 radical 21. And I'm not going to actually leave the answer like this, because not only do we have fractions in the numerator, but we have fractions in the denominator, and we're dividing fractions and fractions. So we do want to simplify our answer to a single fraction. So my first step is actually, if I look in the denominator, radical 7 over radical 21 can actually be simplified. I can divide two radicals, and it's going to become just 2 over 3 radical 3. Now we want to work on getting common denominators in our numerator and denominator. So in our numerator, we have to multiply the first fraction by 3, the second fraction by radical 21. And in our denominator, we have 1 over 1, which we can multiply the top and the bottom by 3 radical 3. So that gives us, in our numerator, we have negative 6 plus radical 147 over 3 radical 21, all over, in our denominator, we have 3 radical 3 plus 2, all over 3 radical 3. So in our numerator, we have radical 147, which we've already simplified in the previous example. So I know that that's going to become 7 radical 3. So now that we have two single fractions being divided, we can rewrite it as multiplication. So we're going to leave it as negative 6 plus 7 radical 3 all over 3 radical 21 times the reciprocal of our denominator, which is 3 radical 3 over 3 radical 3 plus 2. So before I start distributing, I'm going to simplify first. So I have a 3 and a 3 that are going to cancel. And just like before, when I simplified the radical 7 over radical 21, I'm going to simplify this radical 3 over radical 21. So it's just going to become radical 7 in our denominator. So we are going to end up with negative 6 plus 7 radical 3 all over radical 7 times 3 radical 3 plus 2. And distributing into our denominator, we end up with negative 6 plus 7 radical 3 all over 3 radical 21 plus 2 radical 7. And that is going to be our final answer. So that is the exact value of tangent of x minus y for our given sine and cosine values. It's going to be important that when you're using your addition and subtraction identities on your assignments that you take your time and always double check your work so that you don't make a mistake somewhere when you're simplifying. That's going to be the most common way to make a mistake on these. It's not plugging it into the sum or difference identity, it's the simplifying that comes after that. So make sure you're very careful when you're doing your assignment.